In this video, we're going to be working through how can we do inferencing using generative AI at the edge in combination with AMD, one of our partners, as well as the AMD Lemonade server. We're going to go through just a quick introduction. Why are we doing what we are doing? How does the solution fit together and work? We're going to go into a demonstration so you can see how it's configured and the end result, as well as some more information if you're interested at the end. So why are we doing what we are doing? A key reason is from a data sovereignty perspective. We want control of our data. We don't want it to be exposed to public GPTs or public cloud providers. There may be some latency issues, network dependencies. We also want tighter control of the costs. We don't want to be surprised when we are exceeding our token limits or moving between different bands as well. So we want to be able to predict what the cost is going to be for using this large language model and inferencing. What does it give us when we are doing inferencing at the edge? We can do it where it matters. We can put it as close to the assets or as far away from the assets as we need to. It's within your governance structure, so it's within your secure framework. Composable AI workflows, you can decide how you want to use them, how you want to deploy them, how complex do you want to make the data streams for them, or how simple you want to make them. It is also transparent, so you can see all the data that is flowing into them, as well as the data that's flowing out of them as well. So how is this particular solution put together? There's 4 steps to it. The first step revolves around data collection. So how do I collect the data, give it context, and then make it available to the inferencing engine? Number 2 is the local AI processing. This is where the Lemonade server comes into the picture. This is where you can run some of these models locally using the hybrid MPU and the GPU. You can then start doing intelligent analysis. You can bring in this contextual insights, use the large language model to help you understand the data and to give you recommendations as well as predetermined outcomes as you've configured them. And then lastly, the actions piece, which is key. How do I close the loop on these insights that are generated from the large language model as well, whether you're triggering a recommendation or you're passing it to another downstream system? When it comes to putting everything together, it starts with how do I visually see, how do I see the outcome? For us, visualization is the tip of the digital twin iceberg. That is done in our app designer, and it's what end users get to see. It's where you get to see the result and the outcome. What sits underneath the waterline is everything else that supports what we're looking at in the front. The items which are not grayed out are the ones that we are focusing on in this particular video. We're focusing on the data stream and the AI piece. How do I wrangle, provide some analytics, give it context? How do I use the Lemonade server with the inferencing? And then what do I do with the response that I get back from it? How do I drive an action? To understand how the data streams are put together, it helps to go through what is the data stream designer and what are data streams. So data stream designer is an environment in which we configure data streams. This is a visual canvas, allows you to drag, drop, and configure in a no-code way your different data pipelines, whether you're getting streaming data, contextual data, what type of analytics do you want to do in the middle, and then what action do you want to drive on the far right. Data streams themselves need to run somewhere. The logic needs to execute somewhere. Within XMPro, that is where the stream host comes into play. Stream hosts allow us to take the integration, allows us to talk to the various entities. This is a very simplistic view of how the stream host works. The data streams that I described earlier, they run and execute on the stream host using the integration library we've got in the middle here, talking to the entities on the right. When you configure a data stream, we've got one across the top. MQTT is giving us the data. We are then passing that to the Lemonade server to do inferencing, and we're then creating a recommendation. The question is, well, how does this scale? You mentioned putting this at the edge. Right at the bottom, you can see a particular asset, and we have a stream host deployed on that asset. That stream host is running on hardware, which has the AMD Ryzen chip on it, which also has a Lemonade server deployed. The question comes, how do I take one data stream and replicate that across multiple stream hosts? We do that through a concept called collections. Collections allow us to have multiple stream hosts running with only needing one definition of a stream. We publish a stream to a collection. All the stream hosts at the bottom automatically subscribe to that collection, and they start executing the logic. In this particular visual I've got here, each of those stream hosts is installed on a physical device. The Lemonade server you can deploy on exactly the same device, or you can deploy it centrally. It is your choice where you would like to deploy that. What does this look like in practice? If I go into the app designer, this is that tip of the iceberg that I mentioned. The app designer allows me to visually view my digital twin and interact with them. If I drill down to a particular asset, so I'm going to go down to Transformer 4 in this instance. In the middle of the screen, you can see here initial assessment from an AI advisor. As I opened up the page, it had already given me this information. So it's given me a prognostics view of this particular asset based on the data that is available to it. If I scroll a bit further down, you can see it's already given me some priority recommendations. It's done that first level assessment of the data that I made available to it. Again, this is the end user view. This is the result that we're looking at here. So how was this put together and how was this configured? The first step is making sure that you have a deployed Lemonade server and the deployed models that you require. This is the data stream that is sitting behind that created that particular insight. What you'll notice across the top, we're getting telemetry and data from MQTT. On the left, there's a library of a lot of different integration pieces. We are then reading our recommendations, but we're also reading in the prompts. So where we're reading the prompts from. If I go back to the app designer, we have a prompt library that allows you to configure your own prompts for usage. This is the prompt that was configured and is currently running in that particular data stream. You can see in the middle here, this is where I provided that JSON file for the payload coming in, the description, the actual prompt, and on the right, which model and model provider am I using, as well as my token limits. This is configured inside the app designer and gets used inside the data stream designer. We're receiving the data. We are merging the different data sets together. And here we are making sure the data is in a shape that we can pass to the large language model. Down the bottom, if I double click, this is how you configure these particular integration blocks that we're looking at here. On the right, my base URL, where is my Lemonade server running, as well as which model am I using. You can again define a model centrally, or you can use the model that you've defined on the prompt, which means you can mix and match different models for different use cases in different data streams. This is where we are providing the user prompt as well as the system prompt. This is being passed to our recommendation engine, and then we are updating that to get the insight that is being generated by the large language model. Across the top, this is where you can see the collection that it's running in. It is running in a multi-agent generative system collection right now. You have full control to move these as well. Currently, I have one stream host online. If I want to deploy this in multiple areas against multiple assets, I can just deploy one stream host for each of the assets. I do not have to do anything extra on the data stream. So just to recap, we started out looking at the digital twin. We've drilled down into a particular asset. As we opened it up, it gave us the AI advisor piece in the middle. This was done prior to me opening up the screen. There's nothing extra I needed to do. It's done that first level assessment based on the data that is available. So you can see when this particular assessment ran, what the temperature was. It's above the recommended pieces. It's given us an assessment as well as the priority recommendations it's suggesting we should follow through on. What sits behind this is the data stream. If I double click that, it'll open up the configuration for me, and this is how I can configure the Lemonade server with the different models available. If you're looking for more information or you would like to get into contact with how to set this up and use for yourself or your own company, please follow the QR code on the right or any of the links that I've got up on the screen here. Thank you.